Everyone, welcome back. So this time we're going to consider a more complicated example. And so once again, we have to define our position coordinates. We have SA and SB. If you're looking at this, here are our datums, and they're going from fixed points. If both these guys were moving in the same line, we probably would choose the same datum. Since this guy is moving in the horizontal direction, this was vertical, we have two separate points. You could say that the origin is right here if you wanted it to be. But the big important thing is that these datums are taken from fixed points that do not move. Okay. So we can see here, let's look at it all. Well, you can see that this pulley is not going to move, but this one will move up and down as this one moves left to right. Okay. And so some of these pieces of cord are not going to move. Some of those are already red. That's red, and this section right here is red because it doesn't move. What about this height h? Does that ever change? It's something to consider. Now, from this right here, it tells us that h is a constant. We can tell that because it goes from something that doesn't move to another object that doesn't move. So we're not going to have to worry about this as we go forward. At least once we get past our initial writing out the equation for the length. So what we need to do now is write out the total length of our cord. So our length total right here. And we can start from any point we want to. We're ignoring the red section. We have SB here. Then go back up SB. And then we go down H. So 2SB plus H. And then go over SA. You have to just count it up. There are sections that are the same length, like right here. Make sure that you consider them. Keep them that way. Okay. Then we take our time derivative. Well, the total length is going to be constant, and our height h is also constant. And so when we take our time derivative, we're left with only this component and this component. Our time derivatives. That means that the velocity of b is going to be half that of the velocity of a. Or the acceleration of b is going to be half of the acceleration of a, and in the opposite direction, as we have measured our datums. This all depends on where you put your datums. You'll get the right answer as long as you're consistent, pretty much wherever you put it. It's just going to be a lot more difficult if you're not careful. So that is it for this one. We have finished this example problem, and fairly quickly too. So what does this show us? Well, one, we know that as SB moves downward, SA will move to the left. As SA moves to the right, SB will move up. And that makes sense. You can kind of see this going to be true because I'll have more cord here and less cord right here. Now, if you're wondering to yourself, well, what about when this block A hits my little pulley there, or this pulley smacks into this pulley? There is a point where all these equations are going to break down. Obviously, when the system breaks, when you get in line here, there is no more rope. It's just going to pop over the edge. So we're always assuming that SB and other distances, we never reach zero. We never reach zero or try to go past it, because otherwise things break down. Now, we could have worked it out a little bit differently. We could have gone from the bottom point, and this might make more sense to you because you're like, well, there you go. There's an origin that makes sense. That's an origin for both of these. And this would have still worked out perfectly. It's just a little bit different when you're writing it out. And you're like, well, that's big. How am I going to get the length of these ropes if I have this as my datum? Before, the length of the rope was the same as my position vector. Well, it's not too terribly difficult because you can see that this length is simply equal to h minus sb. Okay, so you plug in both of those, h minus sb, h minus sb. Okay, that's all fine and dandy. And if I plug this in, well, you're going to see that's all going to fall out. It won't matter at all. So I'll have 2h minus 2sb. Actually, let me move this down. Let me do it right here. 2h minus 2sb. That's coming from me defining my datum way down here. Plus h. What do I do that? I get 3h minus 2sb plus sa is equal to lt, my total length. And you're like, well, this is 3h plus just a single h. It doesn't actually matter. That disappears because it's constant. It disappears because it's constant. When we take our time derivatives, everything disappears, so we get the exact same answer. Okay? Get the exact same answer. So you don't need to worry. But one thing you might notice right here is look at those signs. Positive on one side and positive on the other. Going earlier, positive one side, negative on the other. So what's happening there is the same result. It's just based on how my datum was set up. Okay, it's how my datum was set up. Depending on how your datum works, it will change the sign here. But as long as you're taking it into account where your datum is, your answer will be the same. My advice is just don't move your datums around during a problem. Keep them at the same place the entire problem, and you'll be fine. Just put them where it makes the most sense to you. So, thank you for listening. I'll see you all next time as we do another example. Have a wonderful time. Goodbye.